Let's study chemistry together with CBSE Chemistry Tips and Tricks.
In a pseudo first order hydrolysis of ester in water, the following results were obtained. First question, calculate the average rate of reaction between the time interval 30 to 60 seconds. Okay. How to find average rate? Average rate is equal to minus delta R by delta T, right? Our time interval is 30 to 60. So what is the equation? Minus of R final minus R initial by total time taken. What is that? 60 minus 30. Okay, time interval is 30 seconds. That is 60 minus 30. Correct, right? Now, what is R final value? See, 0.17 minus initial value is what? 0.31. Initial means what? See, we start the observation at 30 seconds. Okay. So 0.31 is the starting concentration by 30. Correct. So you will be getting like minus 0.14 by 30. So it become what? 0.14 by 30. Correct. See, on calculation you will be getting like 4.67 into 10 raised to minus 3. What is the unit? Mole liter inverse second inverse, that is the unit of rate. Correct. So we got the average rate. Now what is the second question? Calculate the pseudo first order rate constant for the hydrolysis of ester. For first order reaction, we know the equation for rate constant is what? 2.303 by T log R0 by R. Correct. Initial concentration by present concentration. Now what is initial concentration? It is 0.55. Correct. Concentration when time T is equal to 0. That is initial concentration, right? R0. Okay. Now, when time T is equal to 30 seconds, you can find rate constant, say K1. Then for 60 seconds, you can find K2. For 90 seconds, you can find K3. Now, if they are not same, what you do? Find the average of it. Find the average of rate constant at different time durations. Okay. And that average rate constant, you can take it as the answer. So you're supposed to find the rate constant, right? You have to find K1 for 30 seconds, K2 for 60 seconds, K3 for 90 seconds. If they are same, you can use the same number as rate constant. If they are different, find the average and consider it as the rate constant. Okay, we can check. Case 1, right? Case 1. So 30 seconds. Okay, time is 30 seconds. So what is that? K is equal to 2.303 by, what is time? 30 log, what is R0 value? It is always same, 0.55 by 0. Present concentration is what? 0.31. See, I am not showing the calculation part. See, that you have to do by yourself. You have to use a logbook. 1.91 into 10 raised to minus 2. And you know the unit of K for first order, right? What is that? Second inverse. Now for case 2, we can do for case 2, K2. What is that? 2.303 by, time is what? 60 log. Initial concentration is always 0.55 by, what is the present concentration? 0.17. Again, you have to do this by yourself. You will be getting like 957 into 10 raised to minus 2. Now third case, when time T is equal to 90 seconds. Okay, so K3 is equal to 2.303 by 90 log. Initial concentration remains same, 0.55. And what is the final concentration? 0.085. That is the present concentration, right? Okay, on calculating this, you are getting 2.075 into 10 raised to minus 2. Clear? Now, you can see that K1, K2, K3 values are different. So, you have to find average, okay? Average rate constant. Average rate constant. What is that? It's very easy. K1 plus K2 plus K3 by what? By 3 numbers, right? So just add it and divide with 3. 1.91 into 10 raised to minus 2, that is K1, plus 1.957 into 10 raised to minus 2, plus 2.075 into 10 raised to minus 2 by 3. Okay. See, if you want, you can take 1.911. Okay, 911. Okay, now, see, adding and dividing, you will get final answer as, this is your final answer, 1.98 into 10 raised to minus 2 second inverse. Hope all of you understand. Easy, right?